Everybody, it's me, Dr. Gray. I wanted to talk to you guys a little bit about a technique that you're going to be doing for experiment number 5, and that technique is known as a titration. What you are going to be using this for is determining how much of an acid is present in a solution using a base. So with that said, I'm going to go ahead and jump into what is a titration more or less on the next page. So what is a titration? A titration is a technique in which you can use a known solution in order to figure out a little bit more information about an unknown solution. So a titration is going to require a known solution and an unknown solution. Now, generally, whenever we talk about titrations, you're going to be talking about a base, for instance, a sodium hydroxide solution, NaOH, that is a strong base, and an unknown solution is generally going to be an acid, or vice versa. And for this, we'll go ahead and work with HCl as our unknown solution. Now, what this technique allows you to do is know that your unknown solution, for instance, has a concentration of 0.5 molar, which this means 0.5 moles per 1 liter of solution. If you know this information, you can use that to determine a little bit of information about your unknown solution. Specifically, you can know the concentration of that unknown solution. And the way that you can do that is by using the balanced chemical reaction. Sodium hydroxide plus HCl, NaOH plus HCl results in NaCl plus H2O. So an acid plus a base yields a salt and water. Now, with that said, what you need to look at with this reaction is what is the ratio between the individual reactants and the products. So anytime you look at a balanced chemical reaction, you want to make sure that it is actually balanced. So if we look on the left-hand side, let's count up the number of sodium ions or sodium atoms. There's 1 in Na, and then are there any others in any of the other reactants? No, there are not. There's only 1 Na as a product in NaCl. Oxygen, we've got 1 oxygen in our NaOH molecule, none in HCl. We've got 1 in our water molecule. Then hydrogens, we've got 1 from NaOH and 1 from HCl. We have a grand total of 2 hydrogens on our product side, and then finally we have 1 Cl and 1 Cl on the products, or 1 Cl on the reactant side and 1 Cl on the product side. So this is a balanced chemical reaction. What this tells us is that 1 mole of NaOH reacts with 1 mole of HCl. Now, what that means is if you have 2 moles of sodium hydroxide, well, you can answer the question of how much or how many moles HCl are required. And the answer to that is, again, 2. Because our balanced chemical reaction tells us everything that we need to know. 1 mole of sodium hydroxide reacts with 1 mole of HCl. 2 moles of sodium hydroxide require 2 moles of HCl. So what that means is if you have 2 moles of sodium hydroxide and 1 mole of HCl, well then there's a little bit of an imbalance. Is the reaction still going to take place? Absolutely. But are you going to generate as much product? No, you're not. So if we said we had 2 moles of NaOH, 2 moles of NaOH, and 1 mole HCl, what does that mean? That means that HCl is what is known as a limiting reactant. That is going to dictate how much of the products you're going to generate. That one there is going to tell you that you are only going to make 1 mole NaCl and 1 mole H2O. Okay, Now, on the next page, I'm going to dive into this a little bit deeper because we're going to be talking about what do some specific reactions actually look like. So let's use that same reaction. HCl plus sodium hydroxide reacts to produce sodium chloride, our salt, and H2O. Now let's look at the hypothetical situation where we have 36.2 milliliters of HCl with a concentration of 0.6 or 0.596 molar. Okay, so this molarity, this tells us the concentration of the solution, how many moles of HCl are present in 1 liter. Now, do we have 1 liter? We do not. We have 36.2 milliliters, which means our volume is significantly less. Now, with that said, what this is going to, how this is relevant, how we could actually address this sort of problem is we would say 36.2 milliliters of HCl with a concentration of 0.596 molar is neutralized by, let's say 62.6 milliliters of NaOH. Now the key for this in any sort of titration problem is we don't know the concentration, but we can figure this out. Now, one of the ways that we can do it, and I would say the best way to do it, is going to be to figure out how many moles you're actually working with. So since we don't know the concentration of the sodium hydroxide solution, that's what we're trying to find out, and that's what we can find out by doing a titration experiment. But before we get into talking about the experiment, I just wanted to show you a little bit of a demo on how to do the math. Okay, so one of the first things that you need to do is take your volumes and convert them into liters so that you can figure out how many moles that you're working with. Now 36.2 milliliters, well, you can do the dimensional analysis and find that 1,000 milliliters are in 1 liter. So this means 0.036, that's a 362 liters. That's the volume that you're working with there. Now our other volume is 62.6 milliliters. And notice that both of these numbers, well, they're basically the same. We have a number in the ones and the tens position. So we do the same dimensional analysis and come up with a similar number in terms of the decimal place. So 0.0626 liters. Now what we can do is figure out the number of moles of HCl quite simply. So HCl moles of HCl is going to be 0.0362 times our concentration. So volume in liters times our concentration in molarity. So the capital M, 0.596. So 0.0362 times 0.596 equals 0.02157552 moles of HCl. Now, from our balanced chemical equation, we know that if we have 1 mole of HCl, we need 1 mole of sodium hydroxide in order for the reaction to go to completion. In this case, we don't have 1 mole, however, we do have 0.02157552 moles of HCl. So what we need to know is if we have this many moles of HCl, how many moles of NaOH do we need? And to answer that question, well, it's kind of simple. The answer to that is simply the same, because our balanced chemical reaction shows us a molar ratio of 1 to 1. So if we have 0.0215 moles of HCl, we need 0.0215 moles of sodium hydroxide. So now the question would be, what is our concentration? Your NaOH concentration. And sometimes what you'll see, and quite often what you'll see, is rather than the word concentration is used, you'll see a bracketing of sodium hydroxide. So that, what I've written right there, what is your sodium hydroxide, then brackets around sodium hydroxide, that is the same as asking what's your concentration of sodium hydroxide. Well, we know that we have 0.021572 moles of sodium hydroxide. We also know our volume of sodium hydroxide. So we're going to take that number of moles, 0.021572, and divide that by 0.0626 liters. So moles per liter. 0.0215752 divided by 0.0626. This tells us that our solution of sodium hydroxide has a concentration of 0.34465 molar. Now that number we can rewrite as, well, considering our number of significant figures, which is 3, we want to rewrite this as 0.345 molar. So 0.345 molar sodium hydroxide. So that's how you would do that sort of calculation. And I'm going to post another video after a little while that shows the pieces of glassware that we're going to be working with. But for the time being, thank you very much for watching. I hope this helps, and best of luck with the pre-lab as well as the experiment.